Hello everyone, welcome back. In the previous video, we have covered the theory part of the records, and in this video, I am going to create an order class and I will also create an order record, and then we will compare both and we'll see how records provide a concise way to create immutable data classes. I'm going to create an order class, and this class will have four fields named as order ID, product name, quantity, and price. I have declared these fields final because I'm going to create an immutable class and I would initialize these fields using the constructor. So I'm also going to make the class final. The constructor is created and this constructor would initialize all the fields of the class. In order to expose these fields, I'm going to create the getter methods. Getters are created. And if you want to compare two order objects, then we would require the equals method in the order class. So I'm going to generate the equals and hashcode method. Equals and hashcode methods are generated. Now I'm going to generate the toString method. Order class is created. Now I'm going to create a record. Here I have created a record using the record keyword, and this record has four parameters named as order ID, product name, quantity, and price. All these fields are called components, and this record is equivalent to this order class which we have created. So in the record we do not require any constructor. The constructor to initialize all the components would be generated automatically, and instead of the getters, the accessor methods would be generated automatically, and equals hashcode and toString methods are also generated automatically in a record. So we do not need to write these methods in the record. Here we can see that the class contains 57 lines, while in the record we have only 2 lines or even a single line. Now I'm going to create an object of the order class, and then I will create an object of the record, and we'll see how we can access the order class data and how we can access the data from the records. Here we have created an order object, and then we are printing the fields of the order. And then here I have created the record object, and here we can see that instead of the getter methods we are using the accessor methods. So we do not have any getter methods in a record. Instead we got the accessor methods. So these accessor methods are generated automatically. We do not need to write the code for these accessor methods. Now I'm going to execute it. Yes, so in the output we can see there is no difference. What will happen if we pass a mutable object in a record? Let's see. So I'm going to do one thing. I'm going to remove the product name and product price, and I would create one separate product class, and there I would keep these fields. I'm going to generate one constructor that would initialize these fields. And I'm also going to create getters and setter methods. So now in the record, I'm going to use this product. Now I'm going to make some changes to see what happens if the record contains a mutable object. So I'm going to create one product object, and I will pass the product reference in the record. And its price is 2.0. I'm going to remove the product from here. So now I'm going to print the order object. And let me execute this. Yeah, so here you can see the order information is printed. So in the product, we need to override the toString method to display the product name and its price. It's done. Yeah, so here you can see that the product name and product price are printed here. Now what I'm going to do, after creating the record object, I'm going to update the product name or product price. Product has a setter method, so I'm going to update the product name. Now see what happens. Here you can see initially we provided DEF as a product name, but after the creation of the record, we have updated the product name to KLM, and this change is reflecting in the record. So we cannot say that the record is an immutable object now. So in order to fix this, we need to make some changes. So this product class should implement the clonable interface, and then I'm going to write the implementation for the clone method. Clone. Okay, so here this clone is present. Instead of this, I would return a product, and I'm going to perform the deep cloning. So I'm going to create new object, and in the object I'm going to pass the product name and product price. So we are done with our changes here. Now we need to make changes in the record. So in the record, where we should make the changes. So in the record, we need to generate the canonical constructor that will be responsible for initializing the components of the record. Yeah, so inside this constructor, instead of directly assigning the product, we can create the clone of the product and then we can assign it. Now it is saying, it is showing some error. So we need to put the code inside the try catch block. So it is done, and let me execute the code again. Yeah, so here you can see it that the product name is not updated. So it's working. Still there is one catch. So instead of using this product.setProductName, what I'm going to do, I'm going to access the product information from the record, and there I'm going to update the product name, and this is going to be PQR. So this is done, and now I am going to execute this again. Yeah, so here it can be seen that the product name is updated. So in order to fix this problem, we need to override the accessor method for the product. And we have to do the same thing. Instead of directly exposing the mutable object, we are going to create the clone. And we need to do the same thing. Here we can see that the product name is DEF, and which is the name that we provided when we created the record object. If we check the order class, the code doesn't look cleaner, so we can further fix it. we can make it clean. For that, I'm going to do one thing. I'm going to remove this canonical constructor, and I would create one custom constructor. And in this custom constructor, what I'm going to do, from within the custom constructor, I'm going to invoke the canonical constructor that is generated automatically, and that is accessible using the this keyword. So I'm going to pass the order ID, then quantity, and then product name, product dot get name. Okay, so we need to make one more change. Instead of the product, we would use the product name and price. So we are done with the changes, and now I'm going to remove this product name. Now if I execute this code, the output is in the product name, we can see that the product name is DEF. So I'm going to do one thing. I'm going to update the product name. And here we can see it that product name is not updated, because in the custom constructor we are extracting the product name and its price, and then from within the custom constructor we are invoking the canonical constructor. That's it for this video. We'll see you in the next video. Please don't forget to like, share and subscribe.